Let's learn about quadratic functions now. There are three representations of the quadratic functions. The first is standard form, which is given as y equals ax squared plus bx plus c. Second is the vertex form of the quadratic function, which is given as y equals a times x minus h whole square plus k. And the factored form of the quadratic function is given as y equals a times x minus x1 x minus x2. Now there are so many things which we are coming across in the equations in these three forms. First is a, b, c. They can be any real numbers. H, k, they are also any real numbers. Then we have x1 and x2. They are also real numbers. A, B, C are coefficients of x square, x and a constant respectively. H and K, they represent the vertex. Vertex is the maximum or minimum or the turning point for the graph corresponding to the quadratic function. X1 and x2 are the zeros or the roots of the given quadratic function. Now let's learn all these things in detail. Like A. A is called the leading coefficient. For all these, A is called the leading coefficient of the given quadratic function. B is also very important because B and A together, minus B by A, represents the axis of symmetry. Axis of symmetry for the given quadratic function. And C represents the initial height or the initial value or the y-axis intercept, you can say. Intercept corresponding to the given quadratic function in the standard form. This A, B, C are very important terms because they help us to know about so many things of the quadratic function. For example, this A. If A is greater than 0, A is positive. Or I say that A is positive. If A is positive, I get the quadratic function's graph as the U shape, which is like this. As the value of A increases, the values approach each other and the graph gets contracted. If the value of A is less and still positive, then we get the expanded graph for the given quadratic function, which exists like this. Similarly, if the value of A is negative, for example, like if A is negative, less than 0, then we get the quadratic function which is open downwards, which exists in this form. If the value of A is negative, say minus 10, we get the broader graph corresponding to that. Similarly, if A is say minus 1 by 10, we get the I made a mistake. Minus 1 by 10 corresponds to this graph and minus 10 corresponds to the graph which is inside. This corresponds to minus 10, this corresponds to minus 1 by 10 if this graph corresponds to minus 1. So the important thing about the leading coefficient is if A is negative, the graph is open down. If A is positive, the graph is open up. This represents the axis of symmetry. It is symmetric to the y-axis or parallel to y-axis. Similarly, this graph also, it's symmetric to parallel to y-axis. And the y-axis intercept is a point on y-axis where the graph meets. So many things about the standard form we have learned here. Now the vertex. Vertex is the maximum or the minimum point. For the graph which are open up, we have the minimum point, and for the graphs which are open down, we have the maximum point, which is given by the vertex HK, which we get in the second form. Roots are the points on x-axis where the graph intersects. These are the points on the x-axis. If your graph is like this represents the roots corresponding to the given quadratic function. Similarly here, if my line is x-axis is like this, then this represents the roots corresponding to the given quadratic function. So these x-axis intercept are also called the roots or zeros of the quadratic function. Y-axis intercept is represented by C. The symmetry, the axis of symmetry, is represented by minus b by 2a. The vertex is represented by hk, which can also be written as this hk. If we want to write it using the coefficients of the standard form, then we write it as minus b by 2a, and the k is nothing but the function value corresponding to minus b by 2a. We are going to learn about all these things in detail in the coming videos, so keep watching.